Leibniz said, "Everything that is possible demands to exist." Actually, eternal and necessary things do not demand to exist. Their essence is to exist. They have always existed and cannot not exist. On the other hand, all temporal and contingent things, which are always made by combining eternal and necessary things, have the potential to exist, and could exist if the circumstances went their way. Leibniz, unlike modern scientists, was not interested in mere possibility alone. He would never agree that anything that can exist will exist. Against simplistic possibility, he cited the amazing doctrine of compossibility. He explained, "Not all possibles are compossible." Thus, the universe is only a certain collection of compossibles, and the actual universe is the collection of all existing possibles, that is to say, those which form the richest composite. And since there are different combinations of possibilities, some of them better than others, there are many possible universes, each collection of compossibles making up one of them. The key idea here is that true possibility is defined with regard to many things, not one thing. One possible thing has no chance of existing if it is incompatible with everything else. Things can exist only if they belong to vast sets of compatible things. They cannot be treated in isolation, as standalone entities. Science absurdly talks about the random collapse of wave functions. Things can never collapse randomly. Outcomes have to be compossible with what already exists, and that rules out virtually all of the possibilities supposedly associated with probabilistic quantum wave functions. Hence, wave function collapse is anything other than random. If you could really see what was going on, you would see that nothing ever happens randomly, any more than a dice throw produces a genuinely randomly outcome. If you could see what was going on, all the forces in play, you would know exactly what the outcome would be. Sensory ignorance is not ontological uncertainty. Reality knows exactly what it is doing even if you don't. David Hume said causation doesn't exist because he couldn't see it. Causation doesn't care about David Hume's empiricist opinions. It doesn't care whether or not he can see it. Causation is rationalist, not empiricist. Similarly, all the things that science says are random, because science can't see the causal processes at work, aren't. It's actually funny that science lays claim to randomness since no one has ever seen a random event. Scientists interpret events as random rather than causal because of their dogmatic ideology. Their paradigm forbids them from referring to unobservable causal processes, implying a reality more fundamental than science which science cannot penetrate, but accepts randomness as the least threat to science's supremacy, even though, in Hume's terms, randomness is no more empirical than causation, hence no more scientifically valid, and infinitely less rational. Science always chooses the wrong way to think about foundational reality since that reality isn't scientific, and science, like religious faith, can't bear that and fanatically denies it. For Leibniz, there were countless possible worlds, each composed of a compossible collection of the things of that world. Possible things that were not compossible could never exist. This is what science never takes into account. Many scientific probabilities are in fact impossibilities. They are not states compossible with the rest of existence. Any calculation based on countless impossible outcomes is absurd. You cannot average over some results that are possible and others that are impossible. You can only take into account compossible outcomes. This requirement would change the whole nature of science since it would rule out countless possible but not compossible outcomes. Science, as things stand, takes no account of compossibility and instead takes into account all possibilities, even though nearly all of these are impossible in relation to compossibility. Science says crazy things such as a particle can take any route to its destination. It cannot. It can only take compossible routes. In fact, by default, it will always take the shortest route, and no quantum weirdness will ever circumvent this basic law of reality. Why would anything ever expend unnecessary effort and choose a totally inefficient route? Indeed, the idea of mindless material particles choosing anything is impossible. They can't choose. They are mandated to do the simplest, most efficient thing. The fact that we can't observe that they are doing the simplest thing available to them does not mean that they are not, yet scientists start insanely blabbering on about mystical entities taking all possible paths at once. As if. Scientists may be crazy, but reality isn't. It's perfectly rational and always does the most rational thing in the circumstances. All things obey a precise syntax. They don't have any choice over this. Science keeps mistaking empirical ignorance for ontological uncertainty. Reality isn't uncertain. It's certain. Heisenberg's uncertainty principle, if properly understood, is actually all about analytic certainty, but you need to approach it from a rationalist, not empiricist perspective to grasp this. Heisenberg's uncertainty principle concerns infinite frequencies existing at a point. That's the exact definition of an analytic mathematical monad, the basic unit of ontological certainty. But, of course, science doesn't accept the existence of rationalist monads, and so, in the absence of ontological rational reality and certainty, science then talks about empirical uncertainty. If we could actually see what was going on, we would see that there is no uncertainty at all. What there is a vast system of point infinities, monadic singularities, all interacting with each other, making for calculations that involve incredible complexity from the human perspective, and causing scientists to invent the topic of quantum weirdness. There is nothing weird going on. What is going on is a holistic calculation, hence guaranteed to be compossible, i.e., simultaneously involving all monads, which human science cannot yet fathom or penetrate. It's a calculation concerning all non-local minds, not a calculation involving a few isolated material bodies, the only type of calculation science is good at. Science does particular calculations. Reality, by contrast, does universal calculations, which are radically different. Science, because it is all about the particular and not the universal, cannot grasp what is truly going on. To this day, scientists are baffled by the monadology described by Leibniz, and they instead persevere with their ancient atomist model of little local things, atoms, colliding with each other in a box. True reality is nothing like that. It's a giant singularity mind, based on waves, not a huge physical container based on matter. Scientists are so monumentally stupid and prejudiced in favor of materialism that it's effectively pointless trying to get them to see the light. A full understanding of reality is only for rationalists, for mathematicians. Science, for empiricists, will never get there. Leibniz believed that God considered every possible world, which is to say every possible world in relation to the compossibility of each world's constituent parts. God did not consider impossible worlds. According to Leibniz, God evaluated every one of these compossible worlds, each of which had a different value, in relation to God's criteria, and chose to make real the one with the highest value. The real world is therefore, by definition, the best of all possible worlds, the world with the highest value. Leibniz said, every present state of a simple substance is the natural consequence of its preceding state, in such a way that its present is big with its future. This is an absolutely mathematical conception of reality, where causation is built into substance. A key point to bear in mind is that causation too is compossible. A thing surrounded by a few other things might be caused to do A. However, in the presence of many other things, it might be caused to do B, which is radically different from A, i.e., true causation has to take into account the causal properties of all the causally interacting things. This is exactly what happens in a reality composed of nothing but sinusoids, organized monadically. Monadically, all spacetime causation takes place at once, and is calculated across all monads, with the vital consideration that a monad in charge of a particular body can determine that body's particular actions, although it is subject to compossibility like everything else.